Good morning, mathematicians. Let's carry on looking at straight lines and straight line graphs. So we'll have a y-axis and an x-axis. We allow for the possibility down here, let's make sure that this is in the viewfinder, yes. We allow for the possibility down here that y can go to a negative value, and over here on the left that x can go to a negative value. And in this area here, the x values are all positive because we've gone to the right of the origin in this area here, and the y values are all positive up here. So the numbers are easy up here, and we're going to look at lines which mostly go through this part of the graph here. Now, you remember that there were two things about the straight line that we know when we write down its equation. I'm going to write down the equation of y equals, let's see, 2x plus 3. The 3 is the easiest one to deal with. The 3 tells us where the y-intercept is. So here we are, there's the y-intercept at y equals 3, because that 3 is this 3. And that, if you like, tells us the place where the line starts. We say we know that the line starts here. And then we want to know which way it goes. And the direction that it goes in is given to us by the 2, because the 2 tells us the gradient of the line. Let's write those things in. This is the y-intercept. It's very often written just as y-int. For y-intercept. Let's make sure that that's all in the viewfinder. Yes, it is. And here we have the gradient of the line. And in this case, the gradient equals 2. Well, if the gradient equals 2, it means for every 1 along, it goes up 2. So what we can do is we can go along 1 and up 2 to this point, along 1 and up 2 to that point, along 1 and up 2 to that point, and that means that our straight line is going up here like this. There's the actual line travelling along there like that. We can extend the line backwards as well, because if the line arrived at this point and it's travelling in that direction, it must have come from somewhere over here. So our line is doing that. I haven't drawn a very beautifully straight line, but if I had a ruler and if I was using a ruler properly, I would. So there's our straight line. And we know what the straight line is doing because we know the gradient and we know the y-intercept. So let's have a look at some other lines. If we have a line y equals minus x plus 3, well, it's got the same intercept, so it starts at the same place, but the negative x, the minus x, tells us that the line is sloping downhill, and that means this line is going here. I'm going to do this line here with a dotted line instead of a solid line, just so that we can see what it's doing. It's going through this point here, y equals 3 on the y-intercept, and instead of going uphill with a gradient, it's going downhill with a gradient of -1. So our graph before had a gradient of 2. Gradient of 2. This new graph that we've drawn has a gradient equal to -1. Now, we might have to draw our graphs using different information, and I'll put that on another video. But for now, what you need to know is that the constant on the end of the equation tells us where the intercept is, and that means we can move to the appropriate point, to the correct point on the y-axis. The intercept could be negative down here. This, for example, could be a curve, a line, where we had y equals minus, well, the gradient here is quite small. Sorry, not y equals minus anything. Y equals, the gradient here isn't very big. It looks to me to be less than 1. Let's say 0.5 x. And then this intercept looks as if it's about y equals -2. So that would be minus 0.5, that would be a gradient, sorry, that would be an equation of y equals 0.5x minus 2. The 0.5 tells us that the gradient is positive, it's going uphill but rather slowly because the 0.5 is a small number. And the -2, the -2, tells us that the y-intercept is down here below the origin, 2 units below the origin. This is the first of several videos that I want you to look at today, and I'll post the other ones in a little while. Thank you for your kind attention.